All right, this is Calculus 2, 2.2, the derivative as a function. Define the derivative function of the graph of the derivative function. Identify where the function has no derivative. So you guys have done this before. Where can I not take a derivative? Where? At a kink. Where else? A point to point, right? The kink, point to point. What else?
Where it's not continuous.
Very good. It's also not continuous. So I need to have it to be continuous. That's the reason why we've been talking about continuity in first unit. All right, right here, finding the derivative function at number C, f prime. This is using the limit process. But you guys have already done this and you've already gone way beyond this. So if I find the derivative of this function at any number right here, what would I just do? Just do the power thing, right? So let's do that right now. So you guys already know this. So f prime of x is 2x, right? Minus 5. Okay, at any number c. So for any number c, I could say, just plug in right here. So it'd be f prime of c would give me 2 times c minus 5. So whichever number I have there, I just plug in, right? And that's going to, what was the f prime representing again? Do you guys recall? At that point, it represents the what?
Velocity.
Not velocity. So this is the f prime. So not the like the s or the v. This one, the slope, right? The slope of a function at that point. Okay? These ones, slope of a function at that point. So the first derivative, yes, would be velocity, but usually I'm talking about velocity when I'm starting with s. So it'd be s of t or s of something, right? Or v of t. So instead of writing the s prime of t, you would write v of t, right? Because when you take the derivative of s position, you get velocity. All right, find the derivative of this and determine the domain. So now, first, I don't like writing it like that. So I'm going to write it like this. X to the 1/2. If you write it as powers, fractional powers, it makes life so much easier. Because you're going to have a power as a fraction anyway, because when you take the derivative of that, that fraction has to go out in front, right? Okay, so let's go ahead. So f prime of x is equal to, the 1/2 goes out front, right? 1/2 x, and what do I do to my exponent? Subtract 1, right? So if I subtract 1, I get negative 1/2. So if I clean that up, that would be, okay, that goes down to the bottom. So it's going to be 1 over 2x to the positive 1/2, right? Okay, I don't care about rationalizing. This class, you know, you're allowed to have it on the bottom here. On the AP exam, okay, leave it, okay? Don't screw it up, okay? That's usually what happens. You guys could do the derivatives, and just after you try and mess with it later, then, you know, it comes out to be wrong for some reason. So don't do that. All right, so interpreting the derivative as a rate of change. So the surface area S in square meters of a balloon is expanding at a function of time, t in seconds, according to s of t, s equals s of t, and there's my function right here, okay? Find the rate of change of the surface of the area of the balloon with respect to time, okay? What are the units? So, if I take this, so it's going to be s, I said s, come on now, brain work, s of t, when I take that derivative, it's going to give me 10t, right? Yes. Now, S, remember, S, surface area. Surface area. Area is always what? Squared. Very good. Area is always squared. Volume is always cubed. Okay? Always remember that. Area is always square. Volume is always cubed. Okay? So, except if we're talking about like a liquid thing, and then a volume, like a liter is actually a, yeah, that one's actually volume. So, yeah, it's weird. Anyway. Okay, forgive me, I'm off track. All right, so what are the units right here? So we say that this one is going to be what? Square meters, right? So it would be meters squared for this right here. So it's going to be changing this. So it would be my meters squared over seconds. Right? So units are very helpful. Know what you're talking about, why you're doing it, because once we get into related rates, you really have to know what you're doing, because otherwise you're going to screw up everything. All right. So graphing a function and its derivative. So we have find f if f is equal to x cubed minus 1. So if I have f of x is x cubed minus 1, so f prime of x would be what? 3x squared, right? Yes? Okay, so now, always think of this also, okay? If I know the shape, so now you guys ready? Warm up your arms. Warm up your hands right here, okay? You guys ready? Get warmed up. Okay, so do a couple sine waves to get warmed up. Okay, all right, so now, so x to the first power would be what? What would my graph look like? Una linea, right? Okay, so, or if you want to T-pose on that one, okay? All right, so yes. Did you really? Okay. All right, so that's x to the first power. Now x squared. Show me x squared. Excellent. Okay, x cubed. There we go. One down, right? One up, one down. Okay, x to the fourth. It's still up, isn't it? Fourth power, both ends go either up or they both go down, right? Okay? So, same thing. That's an even power. Both ends should go in the same direction. Odd powers, you should have one up, one down, right? Okay, that's really important to understand. So if I'm starting off with an x cubed, I know it's going to start from here, and it's going to go to an x squared, which should be up, right? Or down. Does that make sense? Okay, so yes, during the AP test, if you guys start doing like the YMCA thing, don't worry about it, okay? No one will judge you, okay? All right, so it says right here, the graph here, here on the same set of coordinate axes. So now, when we did this right here, okay, so here's my x cubed, if you notice right here, okay? Now, and here's my x squared right here. Now, I'm going to get a little bit more into detail with this because you guys should already know this. Now, we know that right here, okay, right here, what is the slope of the graph? Positive. So now, if I'm looking at the derivative, these up here, the derivative at this, it's positive, isn't it? The derivative, these are in positive numbers, okay? Positive numbers, positive numbers, positive numbers, positive numbers, positive numbers, right? Okay, so the slope of the graph right here goes to 0, doesn't it? Or, yeah, slope of the graph goes to 0, right? Just as my function goes to a plateau. It levels out right here. And then on the right-hand side of it, it's starting to go up again. Again, my slope is positive, isn't it? It's positive, it's going up. So therefore, that's why the positive, my slopes, again, is going to look like this. So for these points, it should match like that with the slopes of the graph. See, whenever I did this before, when I first took calculus, this always got to me because I couldn't picture it. I couldn't understand it like in my brain. Okay, this, I have to just think of this. Okay, the slope is positive right here, right? So therefore, that the graph of the derivative must be in the positive area. Okay, it must be in the positive area here, right? Okay, so now since you guys are a little bit beyond this, what happens next? So as I do this, so if this was a position problem with velocity and acceleration, my next derivative would be acceleration, right? Okay, so now, so I know right here that I have a positive, 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 right? Okay, my velocity is positive, 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 positive. But now if I do acceleration, I look at the derivative of the derivative. It's going down, isn't it? The slope is going down. So what does it mean if the acceleration is decreasing? It's slowing down, right? Okay, it's slowing down. That's important. Okay, we'll get more into that later, but I just wanted to talk about this because I like this graph. Okay, graph of a function and its derivative. We have this right here. Here is all the parts right here. We have a slope of 0, just like right here. When it comes up to 0, I'm going to have that. Okay, so a lot of things are going to match as you look. It should be one on top of the other. Okay, a lot of things are the same. So find the graph. Use the graph of the function right here. Show in this. Okay, so we're going to graph this. I just set my pen down. There it is. Okay, so we're going to do a graph of my derivative. So we know that right here at this point, negative 2, 3, what do I know? The slope is going to be 0, right? So the slope is 0, so I know that the derivative will be right here at that point, right? Okay, and I know over here at 3/2 negative 2, again, my slope is 0. So that's going to have a plateau right there. So it's also going to be there, right? There we go. So I have some points there. So everything from here, okay, from here all the way to this point is what? It's positive. If you think about it, it's going up, isn't it? Okay, it's going up. So the slope is positive, isn't it? Okay, the slope is positive. Okay, and so now right here, in between right here and right here, right? Right here, my slope is negative. It's negative right there, right? So it's going to be negative, and therefore on the other side, okay, on the other side, so other side of this right here, the slope is positive. So we're going to actually just sketch a graph of what this would be. So it would be, just looking at it, if I had the function, I'd get some better points. Okay, so I know it's all positive into here. So positive, 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 and I know right here it's what?
Negative.
It's negative, isn't it? So it is negative right here, right? And then, there we go. Now, what did we start off with? Okay, what was my function? What type of equation was my function? A cubic, right? That was an x cubed. So if it was x cubed, I know that when I take the derivative of that, my derivative has to be x squared. So it should be a parabola, right? That should be my shape. Do I have that? Yeah. Okay. Yeah, we do. Okay. So if I had the function, I could get like better points of it. But I know it's actually going down, 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 down somewhere. And then right here, it becomes positive again, because that's where this changes direction, right? You know, from a negative slope up to a positive slope, and that's where I get that. Is that helpful? Okay, did I explain that? Are we okay with this? Okay, all right. All right, given the piecewise function, determinant f prime exists. Now, for it to exist, a couple things has to happen. What has to happen? What do we say? The limit has to exist, and it has to be, starts as C, ends in continuous. It's got to be continuous, right? Because I can't find a slope at a hole, right?
No.
Okay, so let's see. If the limit exists, what has to happen? Now, your arms are already warmed up, right? Now let me see those hands. What if the limit exists, what has to happen? Bam, right? Left hand and right hand both go to the same point. Left and right both go to the same point. Okay, good. So now right here. So let's test this right here. So I'm going to do what with this? I'm going to plug in 1, right? I'm going to plug in 1. So if I plug in 1, I get negative 2 plus 4 is 2. Very good. So if I plug in 1 down here, I get 2. Okay, I get 2. All right. So the limit exists, so they both go to the same thing, right? Okay. So let's see. So at that, let's see. So when I do that, it would be equal to on this side, wouldn't it? okay, it would be equal to this side. So I know that is continuous there. Okay, so at that point, I would be only dealing with that. So the derivative of that would be 2x, right? Equals 2x, so f prime of 1 is 2. So it will exist, it is continuous, and I come up with a slope of 2. It's one of those weird ones. All right, you guys ready for the next one? Say yes. Good. Okay, there we go. Oh crap, it's a corner.
Yes, it goes from -8 to 2 real quick.
Damn it. Ah, okay. I'm glad I actually added this graph because I didn't want to be completely wrong. I'm only partially wrong today. All right, so right here, since it is a pointy point, okay, it is changing direction at this. So it is continuous. The limit does exist, but because it is changing direction right here, that is not going to work. Okay, so has a corner, so pointy point corner, so this one's not going to exist for right here. Because one side has a slope of 1, the slope of the top would be negative 4, right? So the slope of the top would be -4, the slope of the bottom would be +2. Since they're changing directions, I can't go with that. So I should have went with that. Dang it. Man, where were you on that one? Man. Okay, so yes, I do make mistakes, and I do have it recorded, so.
Just edit it out.
I know, I could try to edit it. Or I could just like use that as like a teachable moment, be like, hey, yeah, in this video, you see what I did? What not to do, okay? You gotta make sure you go back and double check it and say, hey, right here, so let me see, f prime of the top, it'd be -2x, so that would be f prime of 1 would be -2. It's changing directions, it's not the same, so therefore, bam. So don't make my mistake, okay?
Change the sign.
I know, right? Thanks. Just do me a favor, can you plug in the fan? It's actually getting warm in here. All right, so show that f is equal to, that has no derivative at 2. Okay, that. I know, right? Okay, so now let's go ahead and do the derivative, okay? So start off with, okay, has no derivative, so let's check the sides. So f, dang it. Starting with the limit as x approaches 2 of f of x, so it has to be continuous. Okay, so can I plug it in? Yeah, I can, right? So it's a 5th root. Okay, 5th root, so I would get 0. What's a 5th root of 0? 0. What's 0 to the 4th power? Okay, so now, right there, I have something there, right? Okay, so let's see, what else do we do? Has to be continuous. Is it continuous? Okay, left hand, right hand. So if I do a left hand, right hand on this, okay, what would the left hand of this be? Now, I went over this more with my Algebra 1 class because I didn't think you guys needed it that much. Now, what would be the left hand of this? So the limit of as x approaches 2 from the left hand, okay, from the left side. What numbers are on the left side?
Smaller numbers than 2. So
1.9.
Okay, like 1.9, right? Okay. So it's basically 1.9. So if I say 1.9, so it's 1.9 minus 2, which would give me a positive 0.1, right? Yes?
No negative, because it's less.
Negative 0.1, thank you. So negative 0.1, so it'd be like negative 0.1 to the 4/5, right? Okay, so either way we do it. So if I raise it to the fourth power first, or if I take the fifth root of it, I'm always going to end up with what? A positive number, right? Okay, so I'm going to get a positive number out of this. So there's going to be some type of positive number there. Okay, so positive blah blah blah. I don't know. I'll let you guys calculate that real quick. What'd you come up with? Yeah, we use 1.9, but it was
Yeah.
so we get like a 0.1 to the 4/5. So point what?
0.15.
Okay, so all right. Now let's do the other side. The limit as x approaches 2 from the right. What would I have for 2 for the right? 2.1. Okay, so it's positive 1, right? So f of x would be positive 1. Yeah, positive 0.1 to the 4/5. What do you get? Same number? Okay. Okay, so now I checked it, the left hand, the right hand, it looks like it's getting to that point, right? Looks like it could be going to 0, couldn't it? Okay, so let's check the graph now. That would be the next test. So let's see what the graph would be. So the graph, it's a bird. Okay, so we have parentheses x minus 2 to the 4/5. Enter. Look at that.
Wait, what
How
happened
do
to
we
the
only
last
have
part?
one wing?
Hmm?
What happened to the last step?
Yeah.
Because there should be numbers less than 2 should exist.
Okay, it should. You're right, it should. So trace. It says it's undefined at 0. So I plug in 0, negative 2. I could take the fifth root of negative 2, right? So fifth root of negative 2.
Hi. Negative is, wait, no.
You're right. Okay. So yeah, they were right on this. Because you're taking the root first. That's why. Okay. They want you taking the root first. Alright, so that means that we can't on this side right here. On the left side right here. Because I did the power first. Because if you take that number, raise it to the 4th, it makes it positive, then you could actually do that. But 4/5, that's questionable right there. Alright, I'm going to go with the calculator on this one because, you know what?
Can't you take the fifth root of a negative number?
No.
It's,
You should be able to, because you could do a cube root of the negative number, right?
yeah.
So,
It should work.
I know it should, shouldn't it?
Yeah. Yeah. Did you type it in weird?
I didn't think I did.
Not that one. The
Fifth root of negative 2.
Yours shows that's how it should.
So here's the,
Yeah, I don't get an imaginary from that. Look,
you don't?
nope.
No.
You don't get imaginary from that. So.
Well, I don't even get an imaginary from the fifth root of -2 on my
What is wrong with
calculator.
your calculator, Mr.
Yeah, your calculator's yours in degree and.
Ours is in
Big
degrees
problem.
too.
Hmm.
Mine's
Oh,
a
so
In
is
the
mine.
graph,
What the
you
heck?
typed it
I
in.
know,
We're all in
like-
degree now.
The algebra.
All right.
Yeah,
Okay. It doesn't like it. Doesn't like it here or there. Okay. It says right here that it doesn't like this side for whatever reason. That really gets me. No, that bugs me. I don't mind being wrong, but being wrong twice in one lesson.
But you weren't wrong, your calculator is broken. Because on my calculator, I do the same thing, and it gives me,
Yeah.
Woody just showed that he could do it. Jay just did it too.
I do.
I just thought you could take the fifth root of a negative.
Look,
Bottom
not
line.
ready? -2.
Oh, yeah, there it is. I like mine in gradient.
Yeah, you can
Make default.
Be a long bottom.
I know, right? Oh, I'm looking at the. All right. Okay, I'm doing my. Okay, so we did all this right here. We even did both sides, looking left and right. My calculator says yes. Other people's calculator says no. Okay, I don't even know why. So, but it says here that it's not. It's going to have a vertical. In the book, it actually says that there is going to be an asymptote here at, let me trace, to 0, and then let's go point 1.9. Yeah, it says everything is going to be undefined on that side. That's weird. I don't like it. I don't like it one bit. No, ain't gonna do it. Okay, all right. So I don't know. I'm gonna have to come back to this because this is weird. Okay, so it says graph the function. Does graph have it? Okay, so now right here. So this is not the same one, just so you know. All right. So obtaining information about y equals f of x from the graph of its derivative function.
Click
Does
record.
I think so. Yeah. It's going. Okay, does the graph have any horizontal tangents? Horizontal tangent. There we go. Sorry about this. Okay, so is there any horizontal tangent lines? Say no.
No.
No. Okay, so.
Bless you.
Oh my goodness. Okay, if yes, explain where and why. Okay, doesn't look like any horizontal tangent line. Does the graph have any vertical tangent lines? Did you just say indubitably? Okay, yes, where?
At 2.
At 2?
At 0.
No, I mixed up my
At 0, right? At 0. Okay, this is going to be a vertical tangent line. Okay, now explain why. Identify it right here, where it occurs, and determine whether the point is a cusp of f. Is it going to be a cusp?
What's a cusp?
It's when two curved lines come in and make the kink.
Yeah. So this one right here would be both going. If that is a asymptote, that means that the left side and right side both go up to what?
Infinity.
Positive infinity, right? They both go up to positive infinity. So right there, since I can't really do that, so I'm not really going to get a pointy point, right? It's just going to go up to infinity, isn't it? Okay, so that's going to go up to infinity. So does the graph have any corners? Okay, is there any corners in which I cannot take the derivative? Say no. No, there's no places like that, right? Okay, if yes, explain why and identify where it occurs. We don't have any corners here that which we cannot take a derivative, right? But can we take a derivative at 2? Say no. Why?
They don't leave.
The limit on the left is equal to the limit on the right.
Okay, it's not continuous, right? It's not continuous at 2. All right. Information. Okay. So theorem, function has a derivative at a number c, then it is a continuous at c. Function is discontinuous at a number c, then f has no derivative at c. Okay. So right here, differentiability implies continuity, but continuity does not imply differentiability. Yeah. Okay, so right here, it is continuous at 1 and f prime of 1 exists. So there's my function right there, right? Say yes. Okay, so g is continuous at 0, but g prime of 0 does not exist. Okay, can we take the derivative there? No, it's changing. Okay, so that means that both this side and this side have to have the same, going to the same thing. So now, right here, for c, h is discontinuous at 0, so h prime of 0 does not exist. So it has to be continuous, it has to have a limit, it has to have the f of c, has all that. Okay, there we go. Okay.